nasa school ako today. Yung last week pa. Kasi, wala lang. Mas lalo ngayon kasi nawalan kami ng wifi kasi nung Sunday, yung malakas yung hangin, natakpakan yung wire na daganan. Anyways, let's start. Pinagre-present na.
Dansar.
Sige, start tayo. Makinig kayo. Sabi dito sa problem to, atong problems natin ngayon, problem to, problem to, nasa PDF lang din. Pero makinig na lang kayo ngayon para nang sa ganun, pag nakita nyo to sa PDF, hindi nyo na masyadong aralin. Aralin nyo na ngayon. Sayang yung oras. So, sabi dito sa problem, a W33 by 130 is used to support the loads and moment as shown figure. So, merong loads at saka moment doon sa figure. Pero shown naman yung figure. Neglect the weight of the beam and use a 36 steel with Fy is equal to 248 megapascal. So, here is the property of the section. Paki-screenshot, paki-take down notes. So, we have the properties here. So, ang una nating hinahanap is compute the maximum moment due to the loads acting on the beam. So, ayan yung ating beam. So, ang hinahanap natin is the maximum moment due to the load. So, with respect to the concentrated load here and the moment, of course. Sabi niya kasi, neglect the weight of the beam. Yung dito, yung distributive load dyan, that is the representation of the weight of the beam. Since sabi niya neglect, we will not going to consider that distributive load. So, first thing to do para makuha natin yung maximum moment na nag-act dyan sa beam is to get the reaction. So, we have here the reaction and of course, we also have here the reaction. Sabihin kong this is A, this is point A, at sabihin kong this is point B. So, para makuha natin yung reaction A at B, magsa-summation moment ako sa A. Pwede namang sa B, pero sa A yung gusto ko. So, summation moment A is equals to 0, clockwise is positive. So, tumingin ka dito sa point A, then consider mo itong 90 kilonewton at 90 kilonewton dyan. So, 90 kilonewton times the perpendicular distance na 3 plus the 90 kilonewton, the other one, times the perpendicular distance na 6 moment arm. So, plus din natin yung moment dito since clockwise din yan. So, plus 286. Then we have here the reaction RB. So, reaction B, RB, times natin yung moment arm niya or the perpendicular distance na 9. Then of course, ang RA natin is wala because it has no perpendicular distance. Wait lang, mag-admit lang. So, ayan. Equate natin into 0. So, what is RB? What is our RB, guys? The reaction at B.
Sir, minus RB times 9 yun?
Oo, sorry.
57.78, so.
121 naman sa akin, sir.
121.7.
Sinong
121.78.
Ayan, 121.78. This is in kilonewton. Alam, nag-ano tong kahapon pa.
Oo.
Cardi B ha. So, after nakuha na natin si RD, kukunin natin si RA. So, summation moment tayo, summation Fy or force along vertical is equals to 0, upward is positive. Pagpasensyahan nyo na tong pen, medyo sira-sira ata. So, ang RA natin is upward, kaya positive siya. Ang RB natin is upward, positive. Then, ang 90 kilonewton is downward. So, ganyan. So we have the value of RA. RA natin is equal to 180 minus RB ng 78 kilonewton. So what these are 0.22 kilonewton. So ayan. After natin makuha yung R at RB, gawa tayo ng moment diagram. So meron ako dito. So this is RA. Ilan ulit yung RA natin? 58.22.
22.
Ay, oo. Yung RB natin dito, this is
21.78.
So, ayan. Madali lang natin makuha yung maximum moment kasi simple lang naman yung beam at saka yung loads. So, dito sa ating shear diagram, we have here 58.22 pataas, upward, pataas. Ito, sige. Lagay ko na lang dito. Since yung distributive load dyan is neglected, walang pakialam na, walang load dito, dire-diretso, then we have here 90 kilonewton. So, 90 minus 58.22, paki-compute nga po.
Negative 31.78, sir.
Or 58.22 minus 90, negative
31.78, sir.
21 or 31.
31, sir.
31, sir.
0.70.
0.78.
So, again, dire-diretso lang yan since neglected yung distributive load. So, dire-diretso. Then dito, we have another 90 kilonewton. So, ibababa niya ulit to. Ibababa niya. So, binaba niya. Then, ilan to?
121.78.
Well, negative 121.78.
121.78. So, ayan. Then, pantay-pantay lang to since walang load, neglected ang distributive load. Then, we have a reaction dyan. Itataas niya since upward yung kanyang direction. So, ayan. Pinag-zero niya lang. So, yan yung ating shear diagram. Then, pag tinitignan mo, alam mo agad yung location ng maximum moment kasi yung maximum moment is located sa zero shear dito. So, dito mo malulocate yung maximum moment. So, let's get the maximum moment or try to do the moment diagram. So, dito, meron tayong initial moment since that is a clockwise yung ating moment dyan. Upward agad yan. So, meron tayong upward agad na 286 for the moment. So, clockwise, upward, 286. Then, after that, meron ka nitong positive shear dito, meaning to say, mas iaangat niya pa yung moment. So, kapag inangat niya yan, this is 0 degrees. So, meaning to say, this is 1 degree, straight line. Ayan, inangat. Then, after that, meron tayong negative shear dito, ibababa. Then again, negative shear, mas ibaba mapag 0. So ayan, that is 1 degree. After nyan, ito yung maximum moment natin.
Sir, paano nakuha yung 286?
286 moment. May initial moment tayong 286. Itaas na agad yan. That is counterclockwise. Okay lang din, ma'am?
Yes po, sir.
Okay, so maximum moment natin ngayon, will be, dito ko na lang ilagay.
400.
Ay, na-compute na, sir.
160.6.
Tignan natin. Maximum moment is equal to 286 plus natin yung area ng positive shear, that is 58.22 times the distance. Yung distance dito is 3. So, times 3. So, what is our maximum moment, sir? 400?
460.
460.66.
0.6, oops. 66.
0.66.
kilonewton. So that is our answer. Kilonewton M. Wait lang. So ayan. Yan yung sagot natin for question number 1. So let's start sa question number 2. Ang sabi sa question number 2, number 1. So ang sabi sa question number 2, compute the resisting moment, another moment ulit pero resisting moment ngayon of the beam if full lateral support is provided. Kapag full lateral support, meaning to say yung LB natin 0, itetest na natin agad yung compaction. So i-check natin yung compact, check if compact or non-compact. Siyempre condition for sa compact satisfy na yan kasi LB natin is 0. So, sabihin ko na lang dito. Check if compact or check if compact na lang. So, for the first condition, if it is compact, dapat yung flange natin is continuously connected sa ating web, which is correct, which is compact because we are using the W section. So, continuously connected naman yung flange. So, ang second condition natin is the flange width thickness ratio. Ang sabi doon, the flange width all over the twice of the thickness of flange should be less than or equal to 170 all over the square root of Fy. So, nakuha nyo yung flange width. So, what is our flange width, guys? What is our flange width?
292.354, sir.
So 292.354. How about our thickness of flange, ma'am? I guess
21.717 po.
Thank you, ma'am. So less than dapat siya or equal sa, this is 10.8 since na-compute na natin yan nung first pa lang. So what is this? Yung una, that is
6.73, sir.
So we have 6.73, which is less than siya, I think 10.8. So that is compact. The third condition will be, ang sabi doon, the depth of the section or the depth thickness of web ratio. Sabi doon, the depth of the section all over the depth thickness, I mean the thickness of the web should be less than or equal to 1,680 all over the square root of the Fy. So what is the depth, ma'am, of the section?
840.74, sir.
74. So all over the web thickness kayo po.
14.732, sir.
32.
Yes, sir.
So dapat less than siya into 106.68. That is 1,680 all over square root of 242 ha. So what is
7.07.
07, sir.
07? So that is less than 106.68. So compact. So yung condition for natin, ang sabi niya, ang LC is less than or greater than LB, which is greater than LB lang din naman yan kasi LB natin is equals to 0. Kaya hindi na natin i-compute si LC using the value of L1 at L2, whichever give the smaller value there, that is the LC. So compact na siya since fully lateral support. So compact yung ating section. Once na compact yung section natin, our allowable bending stress, why do we need to get the allowable bending stress pala? For us to get the resisting moment. Submit pa ako, sorry. Kinukuha natin yung allowable bending stress for us to get the resisting moment because allowable bending stress, i-equate natin siya sa MS. So what is the allowable bending stress if compact yung section? Anyone from the class? What is the allowable bending stress kapag compact yung ating section?
0.66 FY.
So, correct. 0.66 FY. Ayan. Under construction ang UCU, guys. Then, itong M dito, that is the resisting moment na tinutukoy niya. So, ang ating modulus section is, or section modulus is, sa property ng section. Ano po?
6653 times 10 raised to 3 mm, sir.
So, what is our resisting moment now, ma'am? Equate nyo to 0.66248.
Divide pa sa 1,000, sir.
Hindi na. Hindi na. Kasi i-divide nyo na sa... hindi na. Yan na, ma'am. Para maging Newton mm. Or i-divide mo sa 1 million para maging kilonewton meter.
In 88.26.
Dinivide na yun sa 1 million.
Times 10 raised to 6.
Pero,
Dinivide ko saan, sir.
ayan, pwedeng ganyan. Or pwede yung sinabi ni Sir na 88.96 times 10 raised to 6. But the unit is Newton mm. So this is our answer. So may tanong sa sa question 2.
Sir, yung ano po, yung condition 4. Paano po yan, sir, yung LC is greater than LB?
LB natin is 0 because sabi ko nga sa lecture, kapag full lateral support ang sinabi, LB is automatic 0. Kaya LC is greater than 0. Ang LC kasi natin, meron yung value. Nung problema natin, di ba, kinuha natin yung value ng LC. Yung value ng LC is yung L1 at saka L2, kung naalala nyo pa. Hindi ko nakukunin yung value ng LC. It's because alam ko na greater than 0 siya. Kasi may value yung LC, positive yung value niya. Kaya hindi ko na kinuha yung value ng LC. Matik na kapag sinabing full lateral support, yung condition 4 is compact.
Thank you, sir.
So, what else?
Sir, yung sa may 2.
2. Condition 2?
Sige, sir. Okay na pala. Given pala yun, sir.
Okay.
Yung sa may constant yung TF. Yung 21.717 given pala.
Given yan, given. So, proceed na tayo sa question 3, ha? Ang sabi naman dito sa question 3 is compute the resisting moment capacity of the beam if lateral support is provided at the ends only. So, pag na-mention ko na to sa lecture, di-mention ko ulit to. Pag sinabing at the ends only, you're going to use the unbraced length, yung LBLB. So, i-use natin ngayon yung unbraced length. May nag-advance study? May nag-review ba sa inyo? May nagsimula lang nag-review? Siyempre, wala. Mag-umpisa pa kayo mag-review baka mamayang gabi or bukas. Bahala kayo. Again, kapag at ends only, we are talking about the unbraced length. So, if we are talking about the unbraced length, we should get the LB, the LC, and the LU. So the LB there is just the span of the beam. So what is the span of the beam? we have 3 plus 3 plus 3 at 9. So we have 9 meter. Or that is equal sa 9,000 mm. The value of LC and LU depends on the value of L1 at L2. So we will going to get the value of L1 first. So ang L1 is 200 times the BF all over the square root of Fy. So we have 200. Ang ating plunge width is, ilan yung plunge width natin guys? 290?
292.354, sir.
Okay, thank you so much ma'am. Then square root of Fy. Fy is 248 because we are using the 836 steel. So what is the value of L1 ma'am or sir? What is the value of L1 ma'am?
3,712.8.90.
Point.
Again, when you are practicing in solving or kapag nag-review na kayo later on, try to write down the formulas, the expressions. It's because for you to familiarize. Kasi makakalimutan at makakalimutan mo to. Pero minsan, kapag sinusulat-sulat mo to, mapafamiliarize na siya ng kamay mo at saka ng mata mo. Parang may mali sa sinulat ko, parang ganito yun. Mas mapafamiliarize kayo. We call that the muscle memory. Magkakaroon ng muscle memory yung mga parts of your body. Kaya try to write down always yung mga formula. So 137,900 all over the Fy natin there is 248 and the depth is, what is the depth? 840 no? 0.74. Kaya medyo nakafamiliarize na din yung yung mga given kasi sinolve namin to kanina. So, ang BF is 292.354. Ang TF natin is 21.71. 717, di ba?
717, sir.
Okay, so what is L2?
Zero 0.000104.
That is a 2? 0 something?
Ay, wait lang po.
Sige, kindly check mo. Po?
4199.13 po.
4199.13. Okay. So, ang sabi ko nga, whichever value give the smaller, that is the LC. So, ang smaller value dyan is the 712.90. And the LU is the bigger one. So, 4199.13 mm. So, ayan. Then, titignan natin ulit yan. LB is greater than LU. And of course, kapag greater than LU siya, greater than LC na rin yan. So, meaning to say, ayan, na-prepare ko na to para hindi ako mag-drawing later on. So, LB natin is greater than LU. Then, LB, syempre, greater than LC na yan, Mati. Kapag ganyan, structure natin, iti-test natin, we're going to test if it is case 1, kung naalala nyo, yung case 1 at case 2, ito yung medyo mahaba-haba na sinasabi ko, or case 2. So, kapag tinest natin yan, we will going to get this, or kukunin natin itong mga value na to. Ang value natin is 7 70327 eh. 327 times CB. Simply supported yung beam natin kaya ang CB natin is just equal to to 1 all over Fy. Then less than L all over RT. The RT is the radius of gyration. The L is just the span of the beam, which is 9,000. Then square root of 3516330 times CB all over the square root of, all over the Fy. So again, case 1 to if this is less than, case 2 to, or case 2 if this is greater than. So we have the value of CB which is 1. We have the value of Fy since we are using the 836 still. We have the value of L. We are looking for the value of RT para makuha natin tong condition na yan. So how do we get the value of RT? Alam natin na ang RT is just the square root of the moment of inertia all over the area. So we were going to get the moment of inertia area. Ngayon, paano natin makukuha yan? Sabi dun sa lecture natin, we should get first the flange and the 1/3 of the half of the web. What I mean is, makinig kayo dito. Makinig po ha, makinig. Kukunin muna natin yung 1/3 ng half of the web. So, kunyari, this is the depth of the web. Kapag unbraced length, matik na bending weak axis ha. So, what is this? Yung depth. Kaya kapag bending weak axis, nakaganito siya. 840.74 ba? Tama, no?
Yes, sir.
Hello?
Yes,
Makinig
sir.
kayo dito kasi medyo medyo komplikado ha, makinig kayo. Kunti lang naman yung ilalaan ninyo. Para kunti lang yung reviewin ay aralin ninyo kapag nag-review kayo. Ayan, late na si sir. So, actually hindi naman, sorry sir, medyo maaga kasi yung klase natin today kaya medyo na-late ka. Pero dapat hindi ka late kasi 2:30 yung schedule mo. Sorry kung inagahan ko po sir. So, ang ating thickness of flange is 21.712, 21.717 I mean. Then this is 21.717. So what is the height or the length of the web? The depth of the web? Kaya nyong isolve? 840.74 minus the twice of the thickness of the flange. So what is the depth of our web?
797.3.
Kunyari ito yung gitna. 797.306.
306, sir.
So 306. So we were going to get the half. So half. So what is the half of the depth of the web?
398.653 po.
398 points. 653.
Yes, sir.
So, ang sabi ko nga, 1/3 nung half ng web. So, ito yung 1/3, kunwari. So, this is the x value. For the x value, that is just the 1/3 of 398.653. So, what is this?
132.88 po.
So, ayan. So, ito ngayon yung kukunin natin the moment of inertia at the same time area. Ayan, i-color ko lang siya. I-shade ko lang siya into yellow. Okay, makinig kayo kung paano kukunin yung moment of inertia at saka area. Yung area madali lang naman. Makinig na lang kayo. So we have here the flange width, 292 point. Ano na yung flange width natin kanina?
354 po.
354, no? Ayan. So also, we have here the thickness of the web, which is 14.732.
732, sir.
Ayan. Ay. Intindihin nyo na lang to kapag nag-ano na kayo. Ayan. Hindi ko pa na-erase to. So, kukunin na natin yung moment of inertia para makuha natin si radius of gyration. So, ang moment of inertia natin, kapag rectangular yung section, what is the moment of inertia? Sige nga. Pag rectangular yung section, what is the moment of inertia? Anyone from the class?
BH cube over 2.
Correct. So, that is in centroid ha, pero iba pa yung transform formula since nakasenter lang sila. So, BH cube over 12. Meaning to say, tumutok muna tayo sa flange. Sa flange siya, sa flange. What is the base sa flange? Kapag ganito yung figure. What is the base sa flange?
1.717.
21.717. What is the height?
292.354.
292.354.
292.354. This is cube. So, all over 12. Plus natin yung 1/3 ng web. Ang 1/3 ng web is, what is the the base?
132.88.
132.88. How about the height?
14.732.
Correct. So this is cube over 12. So what is our moment of inertia? What is our moment of inertia, guys?
Divide by 1,000 ba, sir?
Sige, okay lang.
Cube yun, di ba, sir? Is to 3.
Base to 3.
Oh.
Sorry. Excuse me pala.
45,256.98, sir.
Hindi ba pa ng 1,000 para times 10 raised to 6 na natin? 45?
45,256.98 sa
O 26 times 10 raised to 6. Ganyan, pwede yan.
Yes, sir.
So this is mm raised to 4. So ang area natin, that is just base times height, base times height. So ang base natin sa ating flange is 21.717. The height is 292.354. And sa 1/3 naman ng half ng web is 132.88 times 14.732. So what is the area, guys? What is the area?
1,306.64 mm square.
8,366.64, sir.
Sir.
So ang ating radius of gyration will be square root of the moment of inertia 45.26 times 10 raised to 6 all over 8306.64. What is our radius of variation, guys?
$73.81, sir.
So we have 73.81. So, yung ano condition kanina, masasolve na natin. So ito na yung ano natin ha, condition natin kanina, hindi ko na isasulat yung ano niya, condition niya. Ay yung formula niya. So 7032 70 times CB. Ang CB natin is 1 because it is simply supported times 248. Less than dapat siya sa 9,000 the L. Ang RT natin is 73.81. Then ito, hindi pa natin alam to. This is 3516330 times CB. Ang CB natin is equals to 1 all over 248. So ano yung unang value? Ano to? Yung first one, the first one.
55, sir.
Ilan? 53 point?
25, sir.
Yung second,
121.93, sir.
yung third,
119.07, sir.
so this is greater than. So if that is greater than, this is, anong case to?
Case 2, sir.
So we are going to use case 2. So the allowable bending stress sa case 2, dalawang value yun, which is allowable bending stress is equal to 1172 72100 CB all over LRT squared. So 1172100 times 1 all over 73.81 yun na yung LRT natin squared. So what is our FB? Na una?
215.15,
15.15.
sir.
Ilan?
Sir, yung 9,000 nga.
Ang LRT pala natin. 121 pala. Ang LRT natin. This is RT pala. 121.93.
83.
78.83.
84, sir.
84. Ito totoo. 97, 84, 83.
78.84, sir. Huh?
84. So, isa pa is yung 82,740 CB. Dalawa kasi yung value ng ano dito ay allowable bending stress. Whichever give the small ay bigger value, yun yung ating kukunin. BF, EF. Again, kapag nagpa-practice kayo, take down nyo lang tong mga ano, or write down nyo lang tong mga formula. Ang sa ganon, magkaroon kayo o ma-familiarize nyo. Ang L natin is 9,000. Ang D natin is 840.74 all over. Ang BF natin is 292.354. Then ang PF natin is 21.717. Okay. Memorize ko guys.
69.43, sir.
Yan, 69.43. So, kung ano yung mas malaking value, siya yung gagamitin, which is ito. Siya yung gagamitin. Again, bakit natin kailangan yung yung allowable bending stress? Para makuha natin si resisting moment. So this is less than 0.6 dapat ha. I believe this is 148.8. Nakuha na natin kasi yan nun, nakaraan. So, kukunin natin si value of FB. Ang FB natin is equal to MS, which is 78.84. Ang ating M, yan yung unknown, which is M. Resisting moment. At S natin is 6653 times 10 raised to 3. So, what is our maximum moment? Or I mean the resisting moment? What is our resisting moment, guys?
Sir, but 78.34.
Kasi FB. Ina-compute natin allowable bending stress.
Sir, saan i-divide 1 million ulit?
Okay lang sa 1 million. Okay lang din naman kapag hindi. Ito yung ginawa natin 78.84 kasi bigger value. Di ba dalawa kasi yung value natin ng FB? Yung mas mataas yung kukunin natin. So ilan to, ma'am?
524.52, sir.
Saan mo divide?
1 million, sir.
So, 524.52.
Yes, sir.
52, ma'am.
Yes, sir.
Times 10 raised to 6. This is Newton mm. Right?
Times to 3.
Kahit pag ng times to 10, sir, di ba kilonewton?
Kapag wala na to, kapag kilonewton meter. So, do you have questions sa problem 2 natin?
Sir, yung sa may number, sa may 2, di ba, in-assume nyo na ay yung nakuha ang LB0 kasi full lateral support siya, sir. Bakit nung ano siya, may value na po yung LB sa?
Kasi, ang sabi niya dito, if lateral support, hindi siya full. Lateral support is provided at the ends only, meaning to say that is unbraced then.
Sige, sir, na-pan ko lang.
Hindi, okay lang. So, may tanong pa? Mag-ask lang kayo ng questions, ha? Kung kanina kayo nakikinig, like may pinuntahan kayo, may kumuha ng tubig, tapos may hindi kayo napakinggan, willing naman akong ulitin. Umihi or nakaidlip konti, tapos sa sobrang init, nakagising. Charot. So, kung wala nang tanong, let's proceed sa problem 3. For the last problem in this chapter. So, again, marami kayong isa-solve sa sa ating PDF. Pwede niyang pag-practicean yun. Baka talakit dito baka pinagpra-practicean ninyo itong mga example na naman. Okay, sabi dito, okay na? Punta tayo sa problem 3. Pwede na tayong pumunta?
Sige, sir.
Okay. So, ang sabi